Welcome back, everybody. If you've been following along, we're working on examples 1, 2, 3, and 4 from about the middle of our notes. Today is the 13th, and these are the ones that we worked on in class in preparation for the homework questions that are going to be due tomorrow. Those are separate questions. But we did examples 1 and 2 already in a previous video. We're going to be doing 3 and 4 here. So let's look at number 3. We've got a baseball player that pops up and the ball remains in the air for 6 seconds. So our time is going to be 6 seconds. It tells us that the bat made contact with the ball at 1.5 meters above the ground and the catcher caught it at only 1.25 meters above the ground. So if we think, that's not a very straight line. If we think about this right here, here's your batter, it's holding the bat, and the ball gets struck right here, and a catcher catches it right here. So this is 1.5, and this location is 0.25 right there. So we have our beginning and our end location. We have that is our Y location. Our initial Y is right here, that's 1.5 meters. And our final Y, our YF, is 0.25 meters. Our acceleration is still going to be negative 9.81 meters per second squared. And the question is, what's the initial velocity? VI. That's what we don't know. Okay, so we've got time, we've got initial. Oh, and by the way, let's combine our initial and final y's right here into our delta y. Delta y equals the final minus the initial. That is 0.25 minus 1.5. And that's going to give us a delta y that is a total displacement of negative 1.25 meters. As we look at it over here in our little drawing, from beginning to end, the ball displaced downwards negative 1.25 meters between when it was hit and when it was caught. So we're trying to find our initial velocity. Our initial velocity. Well, we have an equation that relates all three of these. That's our equation number 4. And that's this right here. Our delta y equals initial velocity times time plus 1/2 times acceleration times time squared. Now I wrote it like this. I wrote plus 1/2 at squared. So that tells us that when we finally plug in for a, we have to plug in negative 9.81. I showed you how you can, if you want, you can put the minus out front here, and when you do that, you just simply substitute in 9.81 for a, or actually we call it g because it's the acceleration of gravity. But either way, I'm writing it like this for right now. What do we want to find? We want to find our initial velocity. That's VI right here. The first thing I want to do to get that isolated by itself is I want to subtract 1/2 at squared from both sides. So it's going to be delta y minus 1/2 at squared. That's going to equal VI, our initial velocity, times time. Well, to get rid of the time, we're going to divide that by both sides, on both sides. And all this winds up equaling our initial velocity. Well, what are these values right here? Well, we calculated out our delta y already. That's negative 1.25. Now, here's where we want to make sure our signs are right. We're still going to subtract 1/2. And instead of writing 1/2, I'm just going to put 0.5. 0.5 times a. Well, remember, we didn't change anything about the sign of a, so that has to be negative 9.81 meters per second squared, even though I'm not writing it in, times our time squared. What's our time? It's 6 seconds. So that's 6 squared. All that over our time, which is 6. That's our VI, our initial velocity. So what do we get when we calculate all that out? That gives us 29 meters per second. 29 meters per second. So let's do the second part. And we're actually probably going to have to rely on this to do it. So hopefully our first part is right. There are some problems like this where, if at all possible, try not to use answers from one part of the problem to get an answer to the second part, but I think we're going to have to wind up using this in this one. So we're going to find the ball's maximum height in the second part. Well, at the maximum height, our final velocity equals 0 meters per second. We talked about that today. At the top of a peak, or if you throw a ball up in the air, it's going to be at one instant in time, it's going to be 0 meters per second as it's changing direction. Our initial our initial position is 1.5 meters. We want to find our final position, that is, we want to find our total maximum height. So that's what we're trying to find. So that's this right here. Our acceleration is still the same, negative 9.81 meters per second squared. And anything else that can be useful? I don't think so. I think we have pretty much everything. Oh, well, possibly yes. Our VI is, we calculated from before, is 29 meters per second. That's our initial velocity. Now the question is, can we find the total displacement just by using the acceleration, the final velocity, and the initial position? And the answer is not with the equations that we have. We have to use what we know about the initial velocity as well, because the equation we're going to use is Vf squared equals initial velocity squared plus 2a, and instead of x, I'm going to put y. Okay? So what are we solving for? We're solving for, well, you know what? I'm going to write this as x, because this really was, plus 2ax was our original equation. Let's rewrite this again. Vf squared equals a Vi squared plus 2 times a times, let's write it in terms of y, and let's write it in terms of the two parts of y. Remember, the delta x or the delta y is really the final minus the initial. So that's our yf minus our yi. It's the yf that we're trying to find. So we want to start getting that all by itself. I'm going to subtract vi from both sides. So we're going to have, I'm going to write up here, our vf squared minus vi squared. And then we're going to have to divide both sides by 2a to get that by itself. And the only remaining thing left would be our final y minus our initial I. So we're simply going to add yi to both sides plus our initial y. That gives us our final y. What are these values right here? Our final velocity is 0. 0 squared is 0, so that's easy. Minus our initial velocity squared. Minus, and I'm going to put this in parentheses, 29 squared. So that reminds us that we square the 29 and then we subtract it from 0. So it's the order of operations. We want to do our exponents first. Divide it by 2 times a. And what is a? Well, we didn't do any changing of signs around here. So it's a regular old a, which means we've got to include the fact that a is negative, times negative 9.81 meters per second squared, but I'll leave the the units out for now, although I probably should be writing them in. Add all that to the initial position. It's 1.5 meters. That gives us our YF, which is what? We calculated out. Going to give us 44.4 meters. This is the actual position that the ball reaches at the peak of its trajectory. 44 meters. Not 44 meters above 1.5, but it actually gets to 44.4 meters total. There you go. That's example number 3.